In this lesson I'm going to demonstrate how to get the inverse of this 3 by 3 matrix A here. The first step is to get what's called the determinant of the matrix, and I'm going to demonstrate how this is done. So what you do is you take the top row of numbers here, 1, 2 and -4, I'll just underline them here. And you take each of those one at a time, and each of those becomes part of a term on the right. So just to highlight that, you'll see that the 1 is the first term there, then the 2, and then the -4 is there. What you'll also notice is every second one is plus and minus, so we just better put that in as well. So you'll notice that that's a +1. This is a minus, and this is a plus, whatever the term is, which itself is -4. So that's a plus. So plus, minus, plus, every second one. So that's the first part of the three terms on the right. The 1, the -2, and the plus, -4. Next thing you do is the following. You take each number now one at a time again, and you highlight the row that 1 is in and highlight the column that 1 is in, and you look at what's left over. What's left over is a little mini matrix, -1, 5, 7, -3, and you get the determinant of that. So in the first term, you get the determinant of what's left over. And you repeat that for every, if we just go back there, the next one then for 2, you repeat that for 2. So you take 2 and you highlight the row and column that 2 is in, and you look at what's left over, and you make a matrix out of that. And you get the determinant of that one. And finally you do the same for the -4. Now, next step. So there are your three terms for getting the determinant of the overall matrix, and what you do now is you have to know how to get the determinant of a 2 by 2 matrix. So for example, we'll take this one here, -1, 5, 7, -3, and it turns out that it's a nice little pattern. If you just follow the it's all patterns here. If you follow, it's -1 by -3, and then you go 5 by 7. So you go up for the 5 here, and you do go down for the 7. So it's a kind of a crossover pattern. -1 by -3, take away 5 by 7, and you see that done out here. Maybe I'll raise that a bit. So what I've just done there is the pattern, -1 by -3, and you cross over and get to 5 by the 7. So that's how you get the determinant of a 2 by 2. And you have to do that 3 times. And now it's just a case of working out the numbers, and when you work out all of that, you get the number 2. Okay, so keep that in mind. We have the number 2 here as our answer. And we're going to use, so that's the determinant of the 3 by 3 matrix. The determinant is 2. Next, once we have that, we're going to use that later at the very end, but for now we're going to step 2 of the overall process of getting the inverse of the matrix. So step 1 was getting the determinant. Step 2 is getting the transpose. Transpose is a very easy step actually. It just means switch the rows and columns. So it's like turning the whole in original matrix around by 90 degrees. So if you take that original matrix A there again, and if you just made the rows into columns and columns into rows, this is what you'd get here. That's step 2. It's called the transpose. And next we have to get what's called the cofactors. And the cofactor means there's actually 9 cofactors altogether. There's a cofactor for every term in the matrix, and for example, the first cofactor is A11, and A11 corresponds to the number 1 here. The 11 stands for row 1, column 1, basically. For example, A21, what would that stand for? It would stand for row 2, column 1. So row 2, column 1 would be here, number 2. So A21 would be the cofactor of 2. Just take another example there. What would A31 be? Well, it's row 3, column 1. So this is row 3, column 1. So A31 would be the cofactor of minus 4. So that's the way it works. Okay, so and now hopefully we understand the terminology. We can go and actually work out this thing. Take the first one, the cofactor of 1, 1. Well, there's the term 1. So the cofactor corresponding to that is A11. And what you'll notice again is that the cofactor is just a matter of taking the row and the column that 1 is in, that A11 is in, and looking at what's left over, which is minus 175 minus 3. We've kind of done this already with the determinant. And if you look at what's left over, you get minus 1573, which is basically what's in there. So that's what's left over, and you make a matrix out of that, and you get the determinant of that. So, which is minus 32. And you repeat that process for every single cofactor, and you'll end up getting, for every single term in the matrix, and you'll end up getting 9, you end up getting a cofactor to correspond to every single term in the matrix. So there's all our cofactors worked out there. For example, I'll just pick another one at random just to make sure that you've got this step, and we can move on then. For example, let's get rid of the highlighting first so we can go back. Just take one for example. How did I work out, for example, A32? We'll take this one down here. So how did I work out this term? Well, A32 means row 3, column 2. So if I take row 3, the third row, and column 2, that zooms in on number 5. And what you do then is you knock out the row and the column attached to 5. So you knock out that row and that column, and what's left is 1227, which is what's here, and you get the determinant of that, and that gives you your answer of 3. Okay. Now, when you've all that done, as I said, you get a cofactor that corresponds to every term in the original matrix, and it gives us this matrix here. So we get that matrix there when you put them all together. And there's one more little step here, and that step is to basically, you see there that I've got a second kind of matrix made of signs, and you apply each of those signs to each term in your matrix. So for example, the minus 32, you apply a plus, you multiply it by plus basically, so you still get minus 32 as the answer. Take another one here, for example, take the 3 here, you apply a minus to that, and you get a minus 3 as the answer. So that's what's going on there. It's just, you notice every second one there in that matrix is a plus and a minus. And you end up with this, finally, with this thing that's called the adjoint matrix. So this is the adjoint matrix of the original. It's called the adjoint matrix of A. And the very last step then, step 5, is, don't forget, our overall goal here is to get the inverse of the original matrix A. Now to get the inverse, which is denoted as A minus 1, the inverse of A is 1 over the determinant. We got the determinant in step 1, which was 2. So 1 over the determinant is 1 over 2, which is a half. So there's 1 over the determinant, multiplied by the adjoint matrix, which is what we just worked out there in the last step, which is this here. That's the adjoint matrix. And if you do that, you've now got the inverse matrix of A. That's the end of the lesson on how to get the inverse of A. I suppose one last comment: if you wanted to check your answer, you don't usually have to in an exam situation, but if you ever wanted to check your answer and you had the time, you should be able to multiply A by its inverse, and you end up with the identity matrix. Okay, that's the end of this lesson.